My name is Gray. I will be presenting on NES-related topics. My talk is called Bet You Never Played an NES Game Like This, Innovating Under Limitations. Also, bear with me. A lot of these things are going to be kind of impromptu. I'm running on very little sleep, but so is everyone else. So I have a background in software development and technology research. I generally tend to do more information theory research in general. I run an interactive technology studio called VG Interactive. I kind of accidentally learned how to program for the NES. You'll figure that out soon. And I ended up winning the retro badge category for the DEF CON 26 badge life contest with this badge, a BrainF interpreter. So this talk relates to the NES, as you can probably tell, with the titles in general. But why? Why did I get into the NES in general? 2 Decembers ago, I ended up reading issue 14 of the International Journal of Proof of Concept, or GTFO. There was an article inside of it titled, "This PDF is an NES ROM that prints its own MD5 hash." And the PDF issue itself was an NES ROM as well. And I figured, why not have my resume be an NES ROM? Why not have it be Super Mario Bros? Why not have it be the most convoluted way to pirate video games? And I failed. For a while. So I learned to program for the NES. I didn't know why I couldn't get my resume to be an NES ROM, so I figured, well, I don't know how NES ROMs work, so figure it out. A week later, I ended up making this. It is a very simple kind of splash page for the hackerspace that the toy makers, the badge makers for CypherCon, and I gave that away for their White Elephant gift exchange. So something to note, I have not played with any NES cartridges or boards that Super Mario Bros. Couldn't use. There are a lot of ways in general you can add hardware to cartridges. Heck, you can add Wi-Fi chips to them if you feel like it. I'm only doing what is theoretically possible back in 1985 on Super Mario Bros. Makes my life easier, honestly. So this is the NROM 256 board. There are a few chips on it. The CHR ROM, which is 8 kilobytes of graphical data. It's the tile map, the background tiles, and sprite map. So for Super Mario Bros., it looks like what you see on the right side. There's 2 large squares of, I believe, 128 or 256 sprites and tiles. The right side chip is the PRG ROM, which is the program file in general. It's 32 kilobytes of 6502 machine code. The only thing that matters for the PRG ROM is the last 6 bytes along with the program that you have. But the last 6 bytes are 6502 CPU interrupts. The first 2 bytes of that tells you where the frame starts every frame. So if you're running it on an NTSC or North American NES, it runs at 60 frames per second. If you're running on a PAL region, it's 50 frames per second. Then there's the IRQ, which is the last 2 bytes. We won't worry about that for this talk. So for the PRG ROM, the first 2 bytes specify what happens at the start of each frame, so that I have marked in blue. You can specify where in the code using the address, where in the first 2 bytes there, where that code starts. It can be as long as you want. It can be anywhere in the code that you feel like it. The next 2 bytes specifies what happens when you press reset or when you power on the system itself. So it's kind of the initialization code. You do not have to have that code at the beginning. So you can have blank space above, below, in between, wherever you feel like. It's just a 32 kilobyte block of data. And we can put tons of empty space in there if we feel like it, which would be a little useful. So what can we actually do with that empty space? We can make polyglot files. So a polyglot is a person who is able to know and learn multiple languages that can translate to files in general. So it's a file that simultaneously works as more than one type of file at the same time. So imagine you download some random .jpg file and you can unzip it, or you can play it as a music file. You're not supposed to, by the way. So what makes a file in general? If you download a .jpg image and you change the extension to .mp3 and you try running it in a music player, it's not going to work. But why? It's not the file extension, the last three digits, well, the last three characters in general of the file that specify the file type. It's the actual data of the file itself. Not every file format's the same. I can't just change .jpg to .mp3 and expect sound to work. It's not like those old tape machines back in the day for a Commodore 64 where you just hear the screechy data. It's all just ones and zeros of screechiness. File formats don't tend to work that way. It's a file format that determines if a file is correct. So if you try opening a wrong file type in general, the program you're trying to open it in won't actually recognize it as the correct file. If I just change the extension to .mp3, it will see that it's still a JPEG image, or at least it'll see that it's not a music file. File formats often tend to have a header at the beginning, sometimes the middle, that specifies what type of file it is. And it has these magic strings or signatures, just specific bytes in a specific order, that end up saying, hey, I'm a JFIF file, which is JPEG file interlace format, I believe, or I'm an MP3 file, I'm a NES ROM. Header files are not always at the beginning of the file. They almost always are, but not always. They tell the program what type of file is running, and they might also contain metadata. And metadata, you've seen this on images probably at Facebook. They've gotten in trouble for this years ago, and they fixed the problem where if you uploaded a file, it might contain like GPS data. It might contain like when you downloaded a file, what program you used to create the file, what camera you used to take a picture. This metadata is not the file data. It's important to know that it's not the file data. You can usually remove this metadata and the file will be fine. So for magic strings, an NES ROM, which I'll be talking a bit more about in general, starts with capital N, capital E, capital S, and then the hex address 1A, and it's a 16 byte long string. JPEG images tend to start with FF, D8, FF, PDF files, %, PDF dash. Zip files tend to have PK, 7-zip files, PK, RAR files, PK. So this helps the programs figure out exactly what it's trying to look for. Or if you're trying to run something that can't work, it can figure out very quickly before it even tries putting in processing time that this just isn't going to work. So we want to make a polyglot file out of an NES ROM with that empty space that I talked about before. But what exactly is a polyglot file? Why does it work? So imagine you bought a plot of land and you put a barn there. Does that make that land a farm? If you put a jungle gym there, does that make it a park? If you put a telescope there, does that make it an observatory? It can be all three at the exact same time. It's fine. You're just looking for different headers or tells. Same exact thing can happen for files. So sometimes files tend to look for the header right at the beginning. Almost all file types that I've come across tend to look for it at the beginning. The NES ROM, it has to start with NES 1A. JPEG files has to start with that, FF. And then some are a little bit more flexible. PDF files, it has to start with that PDF header kind of close to the beginning. It doesn't have to be at the beginning, it just kind of has to be close. HTML files are just weird, so we're just going to kind of ignore those. And some expect it really close to the end for some weird reason. So zip files, 7-zip files, RAR files, they don't tend to care what's in front of it. They will try reading the file from the back going towards the front until they find that header. So for an NES ROM, if you're trying to run it on an emulator, it has that PRG data that I talked about before, and immediately afterwards is that CHR ROM data. But the emulator doesn't know how large the PRG file is in the CHR file. So it'll generally end up having a 16-byte header at the beginning, which is that NES 1A, and then some data saying how large the PRG is, how large the CHR is, what region the game came from, so it can figure out if it needs to play at 60 hertz or 50 hertz. We can stick a zip file inside of there. All that matters is that the NES ROM, that INES header thing, must be at the beginning. But because zip files look for the header near the end, as long as we have empty space in that PRG area, we can just shove an entire zip file in it. So back in February of last year, I ended up making an NES ROM that if you had it on a cartridge, dumped the ROM file, you can unzip that ROM file, and it would be a copy of its source code, which you can then compile to make an NES ROM that is a zip file that contains its source code that you can then compile. I will show that off really quick. So we have this NES zip file. I can change the name from .nes to .zip. Shut up, Windows. And I extracted that into this NES zip example, and it contains its source, which, we'll do Notepad. All of its source code, you can then compile that to make the exact same NES ROM that's a zip file that contains its source code that you can compile to make an NES ROM that's a zip file that contains its source code. Let's go back to demos. So there's the CHR and the PRG ROMs in general. Those, at least for what I have done and what they've done back in the day, they would take the data and put them on EPROMs, which stands for Erasable Programmable Read-Only Memory. The PRG ROM is burned onto a 27C256 EPROM, which is a 32 kilobyte EPROM. You can store the 8 kilobyte CHR ROM in a 32 kilobyte EPROM as well. All that matters is the last 8 kilobytes must be that CHR data. So I had a problem when I was making these badges for the DEF CON Indie Challenge, Indie Badge Challenge. I accidentally put the EPROMs in the wrong locations, and unfortunately, graphical data doesn't include programming data, and programming data doesn't include graphical data. And there's about 20 of those cartridges that I accidentally put into the wrong locations. You have to be very particular about it. But what if the CHR ROM did contain the PRG data, and the PRG data contained the CHR data? I wouldn't have to worry about placing an EPROM in the wrong spot. I can just program them with the exact same data, stick any EPROM in any location, and I'm good. Which is exactly what I ended up doing for a few of my projects, made my life so much easier. The PRG ROM data is 32 kilobytes. All that matters is that the last 6 bytes must be those interrupt vectors that I talked about earlier. But I don't need the last 6 bytes of most CHR, like sprite data and tile set data. That can just be garbage, it's fine. So I can take the first 24 kilobytes, use that for the programming data, and then just stick the CHR ROM data in that last 8 kilobytes. So it contains both the CHR ROM data and the PRG data. As long as it can specify where the code starts, it'll run. For all the NES cares, this CHR ROM data at the end could be blank. Which, let's see, with any luck this will run. If it does not, I will just open up in Media Player. There we go. So it's a little hard to see. Have a game inside. I just call this Gemini because it's a twin system sort of thing. I take the cartridge out, and I take the EEPROMs out, and I'm going to swap them. I'm really bad at taking EEPROMs out, by the way, as you can tell. I've blown up the cartridge. Yeah. There we go. So it contains the exact same data. In fact, for the very important gamer badges that I'm doing for the Midwest Gaming Classic this year, I did the exact same thing because I had many hundreds of these to deal with. I didn't feel like having to find different containers to stick all of those EEPROMs into. Let's see if we can get to the next one. One of the consequences of being able to do that is I don't have to have it be the same data in the EEPROMs. I can have it so if I switch the EEPROMs, it's a completely different game. Which there are a few games that I've sold and given away that have that. I'm curious to see how long it'll take before anyone notices which ones. So a little hard to see with this. So there's two EEPROMs in here. If I have the graphical data at the end of this EEPROM for game A, and the programming data at the beginning 24 bytes of this EEPROM, it will be game A. But if I stick the graphical data for game B at the end of the EEPROM that has the programming data of game A, and vice versa for the other EEPROM, I can make a game that is secretly another game as well. Which I also call this one Gemini, but I call this Gemini A and B. This is possible to do, by the way, with, for instance, Donkey Kong. You can end up having a cartridge of Donkey Kong, you switch the EEPROMs, and it happens to be Ice Climber now. So just Gemini B, swap the EEPROMs, and this can be a completely different game. The only thing, there are a lot of games that are small enough to fit all of that data and still make it function, as long as it doesn't care about that last tile, the last 6 bytes of that tile, which rarely do you ever actually have games that care about it. Then you can stick entire games in there, as long as you can get like a reverse engineered, reverse compiled copy of the game. Super Mario Bros. Also works for this. So there's a chip on the left side, the 10 NES CIC chip. This is actually a lockout chip. Nintendo has done region locking since the beginning, essentially. They wanted to make sure that if you have a North American game, you're not going to play it in Europe. If you have a European game, you're not going to play it in North America. This worked as a lock and key system. The lock was the console, the key was the cartridge itself. It's the exact same chip, it just has different pins activated essentially and power going to different pins. This is also an anti-piracy system, so it was a lot harder to pirate, for instance, Super Mario Bros. If you needed to somehow buy a bunch of these lockout chips from Nintendo. Good luck getting the lockout chips if you just want to pirate Super Mario Bros. It also helped deter third-party developers. So if you wanted to make games, and for a while Nintendo only allowed companies to publish, I believe it was 3 games a year. Nintendo wanted a very strict stronghold on what games came out for the NES. In general, many people will blame the ease of development and ease of production of NES, well not NES, but Atari 2600 games for the downfall of the video game market at that time. The Famicom and the NES top loader, the NES 101, which is shown right here, did not include a 10 NES chip, so you can get European games played just fine. There is also one other detriment, in my opinion, of having a lockout chip. You can't do cartridge swapping. While the power's on, if you start playing a game, you can set memory in the CPU RAM, while you're playing the game. If you take the cartridge out, the RAM is still there for a couple seconds. So you can take a game, swap out the game with another game while the cartridge is still on, while the power of the system is still on. and all of a sudden you steal the RAM from that previous game. You can develop games related to that in general, which I did here. If it'll load. There we go. Very easy to get a copy of Super Mario Bros. Duck Hunt. So I decided to play Super Mario Bros. For a little bit. I was one-handed at this time, so don't blame me too much if I suck at it. So I'm getting points, I'm getting coins, I'm getting power-ups. At one point I will get a 1-up. These are all stored in RAM. And the fact that it's Mario and not Luigi at the time. I wanted to get a fire flower. And at this point I can pull out the cartridge, stick another cartridge in while the power is still on. And it's a little hard to read here, but I can figure out exactly what data was in the RAM, read that out, so I can say that I had 3 coins, 4 lives, I was on world 1, the timer was at 321 seconds, 2800 for the score, and that I had a fire flower.
Was that specific to Super Mario Brothers, or can you do that?
Specific, well, so you can develop that for any game.
But you had to do it specifically.
I had to do it specifically for Super Mario Bros., which means if you wanted to have a game that requires you to play at Super Mario Bros., by the way, this kind of has this VIG badge has some fun secrets if you end up playing Super Mario Bros. And cartridge swapping. Just a hint. Let's see if I can get this up. There we go. So on the bottom of the board itself, you'll end up seeing a solder blob and then another spot that doesn't have a solder blob. That determines mirroring. So the PRG data allows you to set what background tiles are on the screen at what point. The screen itself isn't just what you see on the television. It's actually 2 screens wide and 2 screens tall. For ease of use, for like being able to walk off one side and appear on the other side, generally speaking, you'd use mirroring to some degree, or if you wanted to continue moving to the right on a game, you can have the screen scroll and it looks like you're walking around a donut essentially. It's kind of like Pac-Man, but the camera's following Pac-Man rather than Pac-Man moving off the screen. You can choose if you want the game vertically or horizontally mirrored. So for Super Mario Bros., it's a vertically mirrored game. So there are 4 screens. The Super Mario Bros. Data, the screen makes sense if you're moving side scroller like this. If you tried moving on the horizontal screen, you just run into a copy of the screen that you were just in. Things wouldn't load in properly. It looks like a mess. I've accidentally programmed Super Mario Bros. That way a couple of times. It's not fun or easy to play on. You can actually determine if the game is horizontally or vertically mirrored. So you can draw a tile on the screen. You can then check the adjacent horizontal screen, figure out if the file's the tile's the same. If it's not, you can check the vertically adjacent screen, figure out if the tile's the same. So for instance, with Super Mario Bros., there's this little mushroom right here. You can check right here and right here. They're not the same. Check right here and right here. They are the same. This is vertically aligned, well, vertically mirrored. Same exact thing can happen for horizontally mirrored games. So here's just a quick demo. So I've made a prototype cartridge where I can swap out the EEPROMs, one with horizontal mirroring, one with vertical mirroring. If it'll load. Tethering is not fun today. There we go. Very pixelated at the moment. Thank you, YouTube. There we go. So I have the vertically mirrored Enron cartridge prototype board, well, prototype cartridge shell. If I swap that to a horizontal one, it's essentially drawing a sprite on the screen, well, a background tile on the screen then checking horizontally. If it's not there, it assumes it's vertical. If it is there, it assumes it's horizontal. Let's see, I'll just skip ahead a little bit. So at this point, you can actually have the game developer decide what game it is depending on just one solder blob. You can have the game be completely different depending on that. There we go. So the CPU memory of the NES isn't great at all. You have 2 kilobytes of RAM that you can work with, only 2 kilobytes. 32 kilobytes of that is just the PRG RAM. PRG ROM data, about 30 kilobytes of it is either repeats of the working memory or just things you can't really access in general. So you only have 2 kilobytes of working memory to work off of, which is hex address 0 to FFF. 256 bytes of that's actually the stack. If you end up manipulating the stack, bad things happen very quickly. And 256 bytes of that's used for sprite data. Sometimes you don't actually need sprites in your game, so it's fine if you end up modifying that. So the first 256 bytes free memory, then the stack is the next 256 bytes, then the next 256 bytes is the sprite data, which you may or may not be able to manipulate depending on if you actually need sprites. And then the hex 300 to hex 7FF, which is 1 kilobyte plus 256 bytes, you also have for free working memory. But what can you actually do with 2 kilobytes of memory? Turns out not much. So you only have like 1.75 kilobytes that you can actually really use, but JPEG images can be shrunk pretty low if you're okay with horrible quality images. You can manipulate a lot of the memory to put a JPEG image in, but if you modify the stack, bad things can happen. The stack also could essentially be random data. That data will end up manipulating as you play the game. So JPEG images have comments. We can basically just say in the header exif data that everything that should be in that stack area and some places you want to manipulate is just a comment. Ignore it. Don't even bother looking at that data. So we just make a comment that ends at hex 200, or if we want sprites in the game, we can have hex 300. So all of that space that's not the JPEG comment, we can stick an entire JPEG image in, which I ended up doing with an NES ROM of a picture of Lena. Let's see, I'll show this off quick. So I can open up this NES ROM, debug hex editor. So all of this data right here is a JPEG image. There's a little bit of data that's essentially a comment. All of this data up to this point, a JPEG image viewer will just flat out ignore. So we can dump the RAM, set that to lena.jpg, and, oops, one moment, I accidentally wrote the wrong file extension. File, dump the file, RAM, JPG. So if you have a game, you can actually make the hex, you can actually make the RAM a JPEG image. So if you're playing a game that I've made, don't be surprised if I hide some files in the RAM at any particular point. If this is running on an NES, there's a JPEG image running on the NES itself. It's not going to interpret that data, but if you can somehow dump the RAM, you get a JPEG image. It's a very low quality JPEG image, as you can tell, because it's under 1.75 kilobytes in size. And as a general full circle, I tried learning to make NES games because I wanted to reproduce a proof of concept. That was a PDF file that was also an NES ROM. I failed at doing that because I didn't know how NES games work? Well, I thought I failed at it because I didn't know how NES games work. Turns out I went the wrong direction. I didn't know how PDF files worked, and I didn't realize that until like many months into NES development that I went the complete wrong route. I should have looked at how PDF files work in general. But this this presentation in general is a PDF file, so I can release it as an NES ROM as well. Take this presentation. So it is a PDF, it runs as a PDF. I can rename this. .NES. Shut up Windows. There we go. And it's the talk schedule for CypherCon. This runs on hardware. I can make the hardware itself see this as a PDF file. That's a little harder to do considering I wanted a bit more pixels for my presentation than the presentation I gave at Hope Conference in July. I presented from an NES. Oh, I don't have that on me at the moment. I presented from an NES cartridge itself. You're very limited at that point. You have 256 pixels in height and in width and 240 in height. I have just a few more pixels here. So the source code and files, you can end up playing with those. They will be at these addresses. Unfortunately, I won't have the source code and stuff up quite yet. It'll take about a week before I get all of this stuff up. Unfortunately, I still have a couple hundred badges I still have to finish. But yeah, give it about a week and the files will end up being available. In general, special thanks, CypherCon for having me over, Michael Goetzman especially for being interested in the weird NES game stuff I did. I made a TBAS interpreter last year because I needed to be able to practice the programming language on these badges when I didn't have one of these badges to work off of. And why use Python or something when you can make it on an NES. Toy Makers and Rabbit Hole, they've helped me, especially with the Midwest Gaming Classic badges. I have not had much sleep in the last month and a half, and I've been frantically trying to get this talk done, frantically been trying to get the VIG badges done. They've helped me a lot. Johnny Christmas for just being a cool guy. Jakku and Warp World, they are the reason I've decided to get into weird esoteric NES stuff. They've always encouraged me, release a zip file and don't tell them it's an NES ROM. Release an NES ROM and don't tell them it's a JPEG. Angel Bertini, he does a lot of polyglot file stuff. He's one of the reasons why I know how to make files that are other files that are other files at the exact same time. Evan Soltanic and Evan Turan, who wrote the International Journal of Proof of Concept for GTFO article that got me into this in the first place. NESDev forums and wiki, without their information, I would not have been able to figure out how any of this stuff worked. And the Machine Shed LLC, they let me borrow their NES that they disabled the lockout chip of, so I could actually do video of those demos. And that is it.